So we're on the bottom of page 1 in 10.3, and just to make sure we're all clear on this, there's no notes or problem set required. This is a bonus section, okay? And the notes have a typo on it, 10.3, sorry, it's 10.2 is a bonus. So if you would like some bonus points for problem sets that maybe you missed or you were late on a couple, this will make up for that if you complete the problem set for 10.2. So here's what the problems will look like. And the instructions say to solve each quadratic equation by completing the square. So whether or not you can factor it, whether or not you can apply the square root property, this now will do it no matter what, okay? So the first step is to move the c value, any piece that does not have an x involved, over to one side. And it's done for you in number 14. So we have the x squared piece and the x piece on one side and the constant, the number, on the other side. I'm going to give myself some workspace, x squared plus 6x, and a little bit of space equals -8. What we're trying to create is a perfect square trinomial so that we can put it into a factored form of a binomial times binomial that matches itself. So what you do is you take your b value, in this case which is 6, and you're going to divide that b value by 2. So 6 over 2 equals 3. And we're just going to highlight that because we're going to use that piece later. Okay? Then you're going to take that 3 and you're going to square it. So now we're taking the b over 2 that we just found and we're going to square it. And in this case we get 3 squared, which is equal to 9. And we take that value and we're going to add it in to both sides. We're going to add it in here and add it in here. That way we aren't changing the equation. We've done the same thing now to both sides. So we get a plus 9 and a plus 9. So here's what that looks like. So we end up with x plus 3, we end up with x squared plus 6x plus 9 is equal to -8 plus 9. So it's what we had plus our 9, what we had plus 9. And how we got the 9 was we took our b value, the number in front of the x, cut it in half. We're going to reserve that piece for later. We're going to highlight it for ourselves because we're going to come back to it and use it. And then we squared it, so 3 squared equals 9. That's what we added in. What we've created now is a perfect square trinomial. This is now factorable into x plus 3, x plus 3, where the factors are exactly matching. That's what makes it a perfect square trinomial. Now, you can either factor or you can take my suggestion here. When you highlight that 3, that's the piece, that is the factor. That's what you created it to be. So, and then -8 plus 9 is 1. So you can write that as x plus 3 quantity squared, because that's what that means. Something times itself can be written as squared, and that equals 1. And now to solve that, we've got a x squared piece. Now we can use the square root property to solve. And so we've got x plus 3 quantity squared equals 1. We take the plus or minus square root of both sides. What we do to one side, we do to the other. The plus or minus square root does the job of undoing the square, so you just get x plus 3, and you get plus or minus. The square root of 1 is 1, so the answer here is just plus or minus 1. Now subtract 3 from both sides, and you get x is equal to -3 plus or minus 1. So two possible answers, -3 plus 1, -3 minus 1. There's your plus or minus 1. That's an answer of -2 and an answer of -4. So your choices are, for your answer here, solution set -4 and -2. Both of those answers work in the situation. Okay. And we're going to do number 20 here as well, same type of idea. So let's look at, pin set here. We've got an x squared piece and we've got an x piece. We want those on one side and anything else on the other. So we're going to start this one by adding 5 to both sides, giving us x squared plus 6x is equal to 5. Then we take our b value, which is 6, and we're going to cut that in half. which is 3. Save that for later. It just happens to be 3 again. Highlight that for later. Then we're going to take that b over 2 value and square it. So in this case, we're going to take that 3 and square it and get 9. And then we're going to add that to both sides. So we get plus 9 and plus 9. Okay. We're adding it over here, so we create a perfect square trinomial that can be factored into something times itself. We add it to the other side because we want to keep the equation balanced. We don't want to change the value of the equation, so we do the same thing to both sides. When you do that, you end up with x squared plus 6x plus 9 is equal to 5 plus 9. And that factors, again, into x plus 3 times x plus 3. And you didn't have to do the effort of factoring because you created the factor to be 3. That's why you split it in half and why we highlight it for ourselves. It's just x plus 3. And that is equal to 5 plus 9, which is 14. And that is x plus 3 quantity squared equal to 14. And now we have our x squared piece that we can then take the plus or minus square root of. So we've got x plus 3 quantity squared equals 14. And we take the plus or minus square root of both sides. And the square root does its job of undoing the square, so we're just releasing out into the wild that radicand there, the x plus 3. It just undoes it. Nothing changes to the x plus 3. Don't even have to apply the plus or minus. It just undoes the square. And over here you've got plus or minus radical 14, which can't be simplified at this point. And then to solve that, we subtract 3 from both sides. And we get x equals negative 3 plus or minus radical 14. And you can just leave it in this format. It shows your two answers, negative 3 plus radical 14, negative 3 minus radical 14. So it shows both your possible solutions there.